P. Usharani, Professor, S&S Department, RMD Engineering College. I am going to brief about the topic of moving ion instruments. There are two types of moving ion instruments, namely attraction and repulsion type. The name itself, attraction type, single piece of ion piece in a magnetic field. In case of repulsion type, two pieces of iron pieces are used for which are magnetized by the same magnetic field. First type is attraction type moving ion instrument. We have seen the diagram here. One oval shaped disc is there, okay, and control spring. There are balance weights and air friction damping is used. This is a coil. That is how it works means a piece of unmagnetized soft ion is taken near the ends of current carrying coil means the iron piece get attracted towards the coil. Here the oval shaped disc which is made up of soft iron piece which is pivoted on the spindle near the coil. These are the coils here, okay. Whatever the current we are going to measure is passed through the coil, then the coil produces magnetic field which attracts the oval shaped disc. So the disc will be oscillating, that is it is rotating, swing into the coil. So what happened that time? Here the pointer is attached. So how much current is flowing through the coil, the pointer will get deflected. So the amount of deflection of the pointer depends on the magnetic field produced due to the coil, which again depends on the current passing through the coil. So the pointer will show the reading on the meter reading, okay. Here whatever may be the current through the coil, the direction of the current through the coil, the iron disc would always be magnetized. It is pulled inwards. So this type of instruments are useful for measurements of direct current as well as alternating currents. That is the major advantage. Here we are using air friction damping. Why air friction damping is? Eddy current damping we should not apply here because this eddy current damping needs permanent magnets. So these magnets affect the deflection of the pointer as well as the reading of the instruments. So it is preferred here only air friction damping. So air damping chamber is provided here. Control torque. Control torque, both the types are available. We can use either spring control or gravity control, but generally here spring control is used. Why we are not using gravity controllers? There are some drawbacks. What are the drawbacks is we should keep the instrument always in vertical position. So this will increase the weight of the instrument. So better we are using spring control method of control torque, okay. This is attraction type. Next we will see the repulsion type in moving ion instrument. Here for repulsion type, it consists of two soft iron pieces, okay. One is fixed coil, okay, and another one is moving coil. These two pieces are fixed in a coil. This is a coil. Okay. This is fixed coil. This is moving coil. When the current to be measured is passed through the coil, so it will set its own magnetic field. So which magnetizes the two ions, that is the two iron rods with the same magnetic polarity. So what happened? Both are in same magnetic polarity means the two iron rods, that is fixed and moving rods, will repel each other. So the pointer will show the reading on the calibrated scale. Again, the force of repulsion is directly proportional to the square of the current passing through the coil. Similarly, attraction type we have mentioned, no, which is useful for direct as well as alternating current. Here also the two rods, that is fixed iron rod and moving iron rods, will be magnetized and will repel each other. Again here we are using only air chamfer damping. Why we are not using eddy current damping? As this eddy current damping has required permanent magnet, as well as these magnets affect the deflection of the pointer and affects the reading of the instruments. So better air friction damping is provided with the instrument. That is one of the case. Similar to the attraction type, here also we are using only control torque provided by the spring control method only, not by gravity control. We have mentioned the drawbacks of gravity control. One thing is we should keep the instrument always in vertical position. That will increase the weight of the instrument. So control torque can be provided by spring control. Thank you.